I have up here this really strange formula that's looking very abstract with only variables, and the only number here is 0. This is nothing to be afraid of. Actually, this is the formidable quadratic equation. Quadratic quadratic equation. Now, what is the quadratic equation? Well, there we know about regular linear equations. These are my is equal to mx plus b. So that's a linear equation. We know about other equations. Ax cubed plus bx squared plus cx plus is equal to plus d is equal to 0, things like that. There are all these different all these different little equations. Well, this is just another example of an equation. This is a quadratic equation. A quadratic equation has the x term, the highest power of x, the degree meaning the highest power of a variable. The degree is going to be 2. So that is what a quadratic equation is. Now, to show an example, let's add some numbers in here. Let's say let's say x squared. Let's set a is equal to 1. So 1x squared plus let's say 5x plus 6. Okay, so 1x squared plus 5x plus 6, which is really just x squared, which is equal to 0, which is really just x squared plus 5x plus 6 is equal to 0. Now, there are 3 ways to solve a quadratic equation. So there are 3 ways to solve. I'm going to do them in different colors, then we'll see those colors as we try to solve it. The first one is to factor. The second one is to complete the square. And the third way is to use the quadratic formula. Use the quadratic formula. Now, when you let's start by trying to solve this equation. Let's try to use all 3 of these to try and solve this equation. So let's start with method number 1, factoring. Now, when you factor something, let's say that we have the number 27. Now, when you say a factor is, let's say in a multiplication problem, x times y is equal to z. X and y here, these two are called factors. And factors make up a product, but these two are called factors. So if we find the factors of 27, one example is 9 and 3. Another example can be 27 and 1, but let's go with 9 and 3 for right now. So like that, we're going to do the same thing for this quadratic equation. How would we do that? Well, we just have to ask ourselves one question. So let's write this out. So what if I can spell it correctly? What are 2 factors of a times c that add up to b? So of a times c, and they add up to b. Now let's see here. So in our quadratic equation up here, a is going to be the first number in front of x, is going to be the number in front of x squared. So a is 1 because there's an imaginary 1 here. B is the number in front of x, which is 5, and c is the number that's all by itself, which is 6. So now let's plug this in. So what are two factors? What are two factors? What are two factors of a times c? So 1 times 6. So two factors of 1 times 6 that add up to 5. Well, let's start naming the factors of 1 times 6. So 1 times 6 is 6. So factors of 6. Well, we have 1 times 6 and 2 times 3. And anything else is just repeats, which we really don't need. So let's see here. So 1 times 6. Does that add up to 5? No, it does not, unless we were to make 1 a negative. But remember, it's positive 6. So we can't make 1 a negative and try that. But 2 times 3, that multiplies out to 6. And 2 plus 3 is 5. So 2 plus 3 is the answer. Now, so we're going to go with 2 plus 3. Now, here's how it works. So what we have here is 2 plus 3. Now, what we do is we make two sets of parentheses. And we set that equal to 0. And what we say here is x plus 2. So x, the variable, plus the first number. And then in the second step, we're going to do x plus, and then the second number, so x plus 3. Now, if we use the FOIL method, which we learned when you're multiplying when you have things like this to make a binomial, we do is x squared. We multiply the front out, then the outside, so 3x, and then inside 2x, and then last 6. And what we get here is x squared plus 5x plus 6, which is the same thing as what was up here. So x squared plus 5x plus 6. So the answer is, so this is the thing that we need to get. Now, however, this is not our final answer. We need to do one last thing. We need to set we need to set x plus 3 is equal to x plus 2 is equal to 0. And we need to set x plus 3 is equal to 0. Why do we do that? Well, we just pretend like this second part did not exist. So x is equal to -2, and x is equal to -3 by solving for x. And so these are two answers. Yes, it is possible to have two answers when you're working with quadratic equations. Let's move on. Let's skip the second one for now, because that one can get kind of complicated. Let's go ahead and move on to the third one, which is to use the quadratic equation. Use quadratic formula. Now this is a very complicated looking formula that really is nothing. It's like a tiger with lots of hair, but when you shave it down, it's really just a tiny kitten. So what it is x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. Now, this is very complicated, but this really is just a bunch of substitutions. So remember, our quadratic equation is x squared plus 5x plus 6 is equal to 0. So remember, this is a is 1, this is b, and this is c. So let's actually substitute this in. X is equal to minus 1 times a, this is times b, so this is 5, plus or minus, that means plus, you'll have to solve it for when this adding to this, and when it's this subtracting this. So the square root of b squared, so that's 5 squared, minus 4, so times a, so a is 1, c is 6, over 2a, so that's 2 times 1. Now if we simplify this out, 5 times -1 is -5, plus or minus the square root of 5 squared, which is 25, minus 4 times 1, which is -4. Minus 4 times 1, which is 4, times 6, which is 24. So that is minus 24 over 2 times 1, which is 2. Now let's simplify this again. Let's say now minus 5 plus the square root of 25 minus 24, which is 1. So the square root of 1 is 1, plus the square root of 1 over 2. And we're also going to solve it for minus 5 minus 1 over 2. So if we solve that out, this becomes minus 4 over 2, which becomes minus 2. And if we solve this out, we get minus 6 over 2, which is equal to minus 3. So these are our two answers, because remember, this whole thing has x is equal to. So this is solving for x. Now, let's do the third last one. It's slightly more complicated than the other two. It's called completing the square. Completing the square is very important when you're getting into other concepts such as in pre-calculus and continuing into algebra 1 and algebra 2. So complete the square. Okay, this is actually number 2. This is method number 2. Change the brush here. Okay, excellent. 2 is okay. So let's see here. Complete the square. Now, when you complete the square, so we have x squared plus 5x plus 6 is equal to 0. Now, the way we complete the square is we subtract c from both sides. So ax squared plus bx plus c is equal to 0. So I'm just going to walk you through it on this side here. So we're going to subtract c from both sides. So the first step, subtract c. Subtract c. So we're going to subtract c from both sides, so minus c here. Okay, and so now we get ax squared plus bx is equal to minus c. Next we're going to calculate b over 2a squared. So what that means is basically this number divided by this number and then square that. And so ax squared plus bx plus b over 2a squared is equal to minus c. Now after that, we can then factor this out. And then after that we just factor it and then we can solve it. So let's try that over here. So we move c to the other side. So x squared plus 5x is equal to negative 6. Now what we have to do is we have to calculate b over 2a squared. So b over 2a squared, and that's equal to 5 over 2 times 1 squared. So that's 25 over 2 times 1 is 2. Squared is 4. 25 over 4. X squared plus 5x plus 25 over 4 is equal to minus 6 plus 25 over 4. Now, we'll solve this out here, and what we'll find is x squared plus 5x plus 25 over 4 is equal to, this is 1 over 4. Okay, and now once we solve for, now we just have to factor out x. Now once we factor, then we'll just have to factor and solve. Completing the square in this case really is not necessary. It's only necessary when factoring becomes hard to do. Because really what we're doing is we're elongating the quadratic formula here. So really the easiest way would be factoring, second would be use the quadratic formula, and the third would be to complete the square. Thank you very much.